In this video, we're going to look at adding and subtracting rational expressions with non-common denominators. Rational expressions are fractions in elementary school, so these rules for adding and subtracting should look quite familiar. The first thing we're going to do is factor each denominator completely. Then we're going to list the factors of the first denominator, adding to it any of the factors in the second denominator that are not already on the list. Then we're going to form the product of the factors from the list in step 3 and call this the least common denominator. Once we have determined the least common denominator of the rational expressions, we're going to rewrite each one of those expressions as an equivalent expressions, forcing their denominator to be the least common denominator. Now, to do this, we're going to multiply each expression by 1 in the form of whatever factors are needed to be added to that denominator to make it the least common denominator over themselves. So we're going to have equivalent expressions, but with the least common denominator. Once we have that, we're ready to add or subtract the numerators and place the result over that least common denominator. Do not forget that if it's possible, I still must simplify my solution. And I also must remember to state those exclusions. For example, let's subtract these two fractions. I notice they have different denominators, so I also notice that I'm not able to just go straight into subtracting. So the first thing I'm going to do is factor both denominators. I recognize that I have a perfect square trinomial on the left, and I have a common factor of 2 on the right. So I'm going to go ahead and change colors to red and come out here and state my exclusions so that I don't forget in any end. X cannot be 5. That's the only one that causes me problems in both fractions, so that's the only exclusion I have. Now, my least common denominator, if you look at the first one, I've got to have x minus 5, but he's got to have an exponent of 2, so I've got to have 2 of them. Looking in the second fraction, I've got to have a 2, and he's already got the x minus 5, so I don't have to list him again. This is going to be my least common denominator. So on the left, the only thing I need is the 2. So to keep from changing his value, I'm going to multiply him by 1, but in the form of 2 over 2. On the right, he's got the 2 and an x minus 5, but he's missing the second one. So I'm going to also multiply him by 1 because I don't want to change his value. But in this case, the 1 is going to look like x minus 5 over itself. So I have multiplied both fractions by 1, but in the form that I needed to make them have the least common denominator. Now that's going to give me 2x over my least common denominator on the left, minus, I'm going to work this out, multiply that out, that's x squared minus 9x plus 20 over my common denominator. Now I'm going to hit this minus sign every time as I go through. I have 0 minus x squared, that's negative x squared. I have 2x minus negative 9x, so 2x plus 9x is 11x. 0 minus 20 is negative 20. And that'll be over 2 onto x minus 5 squared. Now, to walk you through my ideas on the simplification, since I don't have room to write it out, you're really going to have to listen. I would consider factoring a negative out here so that I deal with a positive x and a positive 20. So if it's a positive 20, when I factor, I'm going to have like signs. This would change to a negative, so they'd both be negative. But I need factors of 20 that will add together to give me 11. Oh, 5 plus 4 is 9. 2 plus 10 is 12. I can't get an 11, so that's not going to be factorable. So as soon as I tell you my exclusion, I'm ready to box in my answer, because that numerator cannot be factored. One more example of adding with different denominators. First, I'm going to change my color to red, and I'm going to come up here and say don't let x be 2, because if you do, the fraction on the left becomes undefined. And I'm going to say do not let x be negative 4, because that would make the fraction on the right undefined. Now my least common denominator is going to be rather simple this time. The left-hand guy has x minus 2. The right-hand guy has x plus 4, so the least common denominator is going to be the product of those two because they're relatively prime. So I'm going to come to the left fraction, and I'm going to multiply him by 1 in the form of x plus 4 over itself, because he needs that x plus 4 in the denominator to get him to the least common denominator. The guy on the right, I'm going to multiply by x minus 2 over himself. Again, that's a 1, so he's not changing anybody's value. And he's going to be multiplied by 2 over x plus 4. That gives both guys my common denominator. So what I'm going to do now is I'm going to distribute on both sides, and then I'm going to write them over just a common denominator. So 3x times x is 3x squared. 3x times 4 is 12x. 2 times x is 2x. And 2 times negative 2 is negative 4. And all of that is over my common denominator of x minus 2, x plus 4. Then I'm going to collect my like terms. So that's 3x squared plus 14x minus 4 over x minus 2, x plus 4. Now at this point, I need to check and see if I can factor the numerator so that maybe, just maybe, something will cancel with what's in the denominator. But when I try, I do 3 times 4 is 12, different signs, so I need to have factors of 12 that give me a difference of 14. Not possible, therefore that numerator is not factorable. Therefore this is my answer, provided that x is not negative 4 or 2. Is not. All right, good luck.